Hello everyone, so in this video we are going to solve a question of LeetCode. There is maximum area of piece of cake after horizontal and vertical cuts. This is 1465th question on LeetCode and this comes under medium category. Alright, so let's start with the problem statement. You are given a rectangular cake of size h into w. This is basically the height into width and two arrays of integers, horizontal cuts and vertical cuts, where the horizontal cut is the distance from the top of the rectangular cake to the ith horizontal cut, and similarly for the vertical cuts. Alright, so basically we have given two arrays. First one is the horizontal cuts and second is the vertical cut, and this is basically each value is representing the distance from the previous cut. Alright, like this one is representing the distance from 0 to 1, this 2 is representing the distance from 1 to 2, and this 4 is representing the distance from 2 to 4. Alright, so these are basically the values of cuts that we have in this rectangle. Now we need to return the maximum area of piece of cake after you cut at each vertical and horizontal position provided in the array. Alright, so basically we need to find out the maximum area of this rectangle. Alright, any of the rectangle which is formed after these cut, we need to find out the maximum area among these. And since the answer can be very large, we need to return this into modulo. Alright, so let's see how can we approach this question. So basically in this question, in the first example, we have h is equal to 5 and w is equal to 4. So the height is 5, okay, and the width is 4. Alright, and we have basically given 3 cuts for the height and 2 cuts for the width. So what can we conclude from here? Let's say in this we have one rectangle here, second rectangle here, third is here, this is fourth one, this is fifth one, this is sixth, this is seventh, this is eighth, this is ninth, this is 10th, okay, this is 11th, and this is 12th. So basically in this question, in this example, we have 12 rectangles. Alright, and the maximum area which is formed by the rectangle is equal to this one. Alright, because this middle one, 8th rectangle, is containing 4 rectangles into it, or we can say 4 squares into it. So this is basically giving the maximum area. Okay, so we are returning 4 because there are 4 rectangles here, or we can say the height is 2, okay, and width is 2, so 2 into 2 is equal to 4. Alright, so I hope the example is clear to you, because like if we see for other rectangles, for this first one the area is 1, for second one the area is 2, okay, the third one, like the third rectangle here, the area is again 1, for 4 is 1, for 5 is 2, for 6 is 1. Alright, so these are basically the areas. So what we can do is we can directly find out the area of the maximum one. Let's see how can we do this. Okay, so let's say we have given this example, the first example. So in the first example, first we can see the gap between two cuts. Okay, the maximum, like the maximum the gap, the maximum area we can get. All right, like in this the maximum gap is between 2 and 4, that is the 2. Okay, else everywhere we have only one gap. All right, like I think you can observe this, the gap between these 2 and 4 is the maximum, that is 2. Similarly, the gap between 1 and 3 is also maximum, that is 2. Else everywhere this is 1 only. Alright, so whenever we get the maximum gap, we will just take that value. Like in this case, we have the maximum width is 2 and here the maximum height is 2. So we can find out the area from this, like maximum height into maximum width. Okay, this is 2, this is maximum height is 2, and the maximum width, let's say this is 2. Just clear this, yeah, so this is 2 and the maximum width is also 2. Okay, so total we get 4. So this is a very easy question. I hope you are able to understand this. So let's see what are the steps we gonna follow to solve this question. So the first approach which we gonna follow is, first we will add the last element, this is 5, into this horizontal cut. Let's see why we are adding this. We are adding this because, like in this example, let's say in the second example, we have the last boundary here at 5. Okay, we have the last boundary at 5. So if we want to count this rectangle, so definitely we need a value here. So like in this case, the horizontal cuts are 1 and 3 only. So we will be adding 5 also here. Okay, to calculate the height of this area. It is 3 minus 5. It is 3 minus 5. That's why we are adding the height in this array. Alright, similarly we are adding the width into this vertical cut since we have only one. Okay, so in this case we can only get this value, that is 0 and 1. So this is 1, but we also want this value because this is also forming a rectangle. Alright, so what we can do is, in this array we can also add one more value, that is the maximum width. So maximum width is equal to 4. It is the total width, so we will be adding 4 here. Okay, now what we can do is we can find out the distance between 1 and 4. That is, this is 1 and 4. The distance between 1 and 4 is equal to 3. Okay, so how can we find out the answer in this case? Like this is 1 and 4, so 1 minus 4 is equal to 3, and in this 3 minus 5 is equal to 2. So 2 into 3, okay, 2 into 3 is equal to 6. So we are returning 6 from here. Alright, so I hope this approach is clear to you. So let me write here. First, we will just add the values into arrays. Okay, arrays adding value. Okay, we will just add the value into the array. And second approach, which the second step we gonna follow is we will just sort this. Okay, we will just sort this because we are just calculating the space between the adjacent values. Okay, that's why we will just sort this. Okay, let's say we will just sort this. Okay, we will just sort this array, like this is 3, 1 and 5. Okay, so after sorting we will get after sorting, let me just clear this. Yeah, so after sorting we will get 1, 3 and 5. Similarly for this, after sorting we will get 1 and 4. Okay, so the second step we followed is we just sorted this. Now third one we will just find out the maximum height and width by subtracting these two values, that is 1 and 3 and 3 and 5. So we will find maximum values. Okay, and at the end the fourth and final step is finding out the area to return as answer. Okay, to return as answer, the maximum is 2 in this case and 3 in this case, and the area is equal to 2 into 3 is equal to 6. Alright, I hope this is clear to you. Let's quickly code it up. So first let's take the mod value. Okay, let's take the mod value, that is int mod is equal to 1e9 plus 7. This is the mod value. Now let's take the maximum width and height. Okay, this we need to find out to find the area. So let's take long because it can go up to 10 to the power 9. So let's take long int is equal to, let's take long int first is max height, that is equal to 0 initially, and max width, that is also initially 0. Okay, now let's add the ending element, or we can say the height and width, into our horizontal cuts, and it is vertical cuts. So before that, let's just sort this variable names because it's too long and it will take a lot of time to type. So let's take, this is horizontal cut and this is vertical, so let's make it VC. Alright, now let's push H into this HC and W into this VC. So HC dot push back H and vertical cut dot push back width. Alright, now let's first sort both the arrays. So sort HC dot begin and HC dot end. Similarly, let's sort VC. So sort vc dot begin and vc dot end. All right, I hope this is fine. Now let's find out the maximum height and width. So let's iterate through these arrays. So int I is equal to 0. Also take one more variable, that is previous, to find out the previous value, like this 3. So we are just storing the 1 as the previous value here. So initially it's 0, so previous is equal to 0, and we will be updating in the each iteration. So and I is equal to hc dot size and I plus plus. All right, now let's update max area, max h. So max h is equal to maximum of max h comma, that is vc, that is hc. Okay, it is a horizontal cut array, so hci minus previous one. All right, and let's update previous with current value so that we can use this as the previous value in the next iteration. All right, similarly let's find out the maximum width. So for int I is equal to 0, previous is equal to 0, and I should be less than tickle cuts dot size and I plus plus. Let's update max width, that will be equal to maximum of max width and horizontal, that is vertical cuts I minus previous. All right, and let's update previous to the current value, it is vci. All right, this is fine, I guess. Let's, okay, we are taking long int, so we will be updating, like we will explicitly converting this to long int because this max h is int long int. So to compare both the values, both the data types must be same, so we will be just explicitly converting this to long int. Similarly for this, let's update long int. All right, this should work fine. Let's return area from here. So return long, let's return area. So this should be max of height into max of width, and let's take mod so that it must be returning under the range. So mod, and yeah, let's run this. Yeah, it's working fine. Let us submit it. Yeah, it's working fine. So let's calculate the time and space complexity of our solution. So the time complexity of our solution is big O of n log of n. Okay, plus we can say this is the size of first vector is n and the size of, let's say, second vector is m. So this should be n log of n plus m log of m. All right, this is the time complexity. And the space complexity, since we are using constant spaces here, but this sorting function will take log of n. Okay, so the space complexity is log of n for this horizontal plus log of m for this vertical cuts. All right, so these are basically the time and space complexity of our solution. So that's it for this video. I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.